Okay, which student performed the best on the last test when compared to the rest of their class? Okay, so we fixed the formatting on this a little bit. All these were the mean, basically, and this was the standard deviation numbers there. So first number mean, and the next one is standard deviation. So what we want to do for these is we want to figure out the z-score. So our data point is 17. Take away the mean, which is 15, and then divided by the standard deviation of 2.4. And then that is going to give me a z-score. So give me just a second. I'm actually not doing this with a key, so I have to do the problems as I go. So give me a moment. So this student, obviously it's going to be a positive z-score because it is above the mean. Okay, so it's in the top half of the bell curve, and that is a z-score of 0.83 repeating. So they're almost one standard deviation away, which makes sense because a standard deviation or a z-score of 1.0 would be 2.4 away. So if you think about this, like a score of 17.4, if that's possible, would be a z-score of 1. Okay, so being just under 1 really makes sense for that problem. So for 2, this time we're going to do the same thing but with the number 18. And now we're going to have 3 divided by 2.4, and that's going to be 1.25. All right, so what we're looking for here is which student performed the best. And I'm not going to do all of them, but I've done 2 of them now, and I think you get the pattern to do C and D. And I can tell you that this student performed better than, so this student right here in B performed better than A because they were over a full standard deviation above the mean. Number 3, there are 3,000 students in your school. You surveyed 100 random students about their favorite food, and 5 of them say salad. How many students in the whole school would you estimate would say that salad is their favorite food? Okay, so we got 3,000 students in our school, and we went about surveying 100 of them. So let's see, what other information do we know here? How many students in the whole school would you estimate? And 5 of them say salad. Okay. So we know that 5 out of 100 like salad, and the whole school is 3,000. So I look at this problem like this, and I think we're pretty good at this. So basically, it's just 5% of 3,000, which is 150. So I'm going quick again. So when you're writing this out on the test, make sure you state 150 students. 4, sample of 200 people in the school were surveyed about their IQ, and the data is normally distributed. The average is 100, standard deviation of 15. How many people are in between 90 and 120? Okay, so this one, we have to find basically the percentile for that, and then the percentile for that, and see what the distance is in between them. So I'm going to find the z-score for 90. I'm going to go 90, take away my mean of 100, and then I'm going to divide it by my standard deviation of 15. And that's going to give me 10 over 15, which is 0.67 repeating. Okay, so we need to go and find that on our z-score chart, and I'm hoping I have that in here somewhere. That is a class list. Oh, come on, there's so much stuff in here. Yeah, here it is. Okay, so 0.67 on here is going to be right here. Oh no, I'm sorry, I'm doing that incorrectly. I'm rushing, I'm going too fast. All right, so 0.67 is 0.67, which is going to be this cell in the data right here. Now don't just say about 74 or 75%, we want to write it all the way out. So that is 74.86%. So so for 90, it's 74.86%. Now we've got to do the same thing for 120. So I'm going to go down here and I'm going to plug in 120, which is going to give me 20 over 15, which is, let's see, 1 and 5, which gives me 1.3 repeating. So I go back to my z-score sheet, and this time I locate 1.3, which is right here, which you can see is 90.82%. 90.82%. Okay, I messed up, and I'm not going to redo the whole video, so hopefully you guys have already picked up on where I went too fast and made a mistake. But let me tell you how I knew that I made a mistake. When I knew that this is the correct number, that this person right here with the IQ of 120 is in the 90th percentile, and then I was about to say the person with the IQ of 90 is in the 74th percentile. I was like, what? That doesn't make sense. That doesn't make sense because 90 would be below the average, therefore below, it would be below 50%. Okay, but so what I'm going to do now is basically the number that we needed to find was, remember how it was, what was it, 0.67? We needed to find negative 0.67. And then whatever that percentile is, we need to write right here. And then we're going to subtract them to find the difference. So when you do that, you're going to get your answer right here, okay? So find negative 0.67, write that number, write that percentile here for that z-score, do your subtraction, and then you'll have how many people, oh no, we don't just need a percentile, we need how many people out of 200, okay? Maybe I better do this. The only reason I didn't is because I wasn't sure if I have a negative z-score sheet in here anywhere. So let's see if we get lucky. That is a positive one. I'm not going to look too long, guys. I think you guys can do this, and if this problem confuses you, just ask me about it in class. But basically what you're going to do is you are going to subtract and get this percentage. And then whatever this percentage is, you need to take that percent of 200 because they're asking for the number of people in between 90 and 120. Okay, made a big mess here. All right, the spacing on the test will be much better too. This is kind of not a lot of room to show your work. 5, 2 normal curves have been graphed on the same axis. They have the same mean with different standard deviations. Describe the curves. How do they look and why? Okay, 2 curves have been graphed on the same axis. They have the same mean but different standard deviations. Okay, so we talked about high standard deviation and low standard deviation. So if we have one curve like this, okay, that is a high standard deviation because it's very spread out from the mean. And if I have another one that goes like this, the data is more clustered around the mean and it has lower standard deviation. So it's kind of opposite of what you would think. The tall one is low because there's not a lot of variation, and the low one is high because the data is very spread out. So they have the same mean, but they can look different based on their standard deviation. So I'll use a different color here. This one here with high standard deviation, this would have a bigger number as a standard deviation because it would be more spread out. This one could have a very low standard deviation because it's going to just be real close to the mean like that. 6, data has been collected and a normal curve has been created. What is the likelihood that your data will fall outside 3 standard deviations? Good question. So remember, our first one goes like this, and it goes 34, 34, and then it goes 13.5 and 13.5. And so far that has added to that is added to 95%. But we need to go out 3 standard deviations, and we're wondering, you know, what are the odds it's going to fall outside of that? So basically, these add to 95, so we're talking about these last 2 blocks, this one and this one, they're going to be half of 4.7, which I know this, but I just want to be sure, which is 2.35%. So these ones out here are 2.35 and 2.35. So we're wondering, you know, what area is left out here? Not much. I mean, it can extend for a very long way. But, you know, what is left out there? Well, that would be just 0.3% divided by 2, which is 0.15%, not 15%, okay? But basically, we just have 0.15 on each side. So what's the likelihood that it will fall out there? Well, that would be 0.3%. Okay, I think I'll, let's see how much of this I have left. Oh, not much. Okay. I think I will make a third video just in case this is too